name is Taylor McEwen.
I'm Lizzie Morowitz.
I'm Kimberly Sminsky.
I'm Lindsay Gardner.
And we worked on the project Migration Assay for Improving Chronic foods. In this project, we used cell culture to determine the effects of a protein on cell migration. Potentially, this protein can be used to help treat chronic foods. However, before we can understand how to help heal chronic wounds, we must understand how normal wounds heal. Most wounds heal in a process known as the wound healing response. Directly after an injury happens, the blood vessels constrict and a clot forms to prevent bleeding. And then, in the inflammatory response, white blood cells migrate into the cell, into the wound, to prevent infection and clear away debris. And then, in the proliferation response, Fibroblast, a type of skin cell, migrate towards the center of the wound to close the wound. This is the phase of the wound healing response that we simulated in our scratch assay. And finally, during the remodeling phase, skin cells synthesize collagen to strengthen the scar tissue. If something goes wrong in the wound healing response, the wound will not heal and will become a chronic wound, and just a warning that restitution is on the next slide. Elderly, bedridden, diabetic, and obese patients are most at risk for chronic wounds, and chronic wounds impose a great burden on the patients. For example, diabetic foot ulcers, shown here, most often result in amputations. Moreover, more than $25 billion are spent on chronic wound treatments each year. And the current treatments are not as effective as we would like them to be. For example, IPC, or intermittent pneumatic compression, is like hooking up a vacuum to the wound to apply pressure so the fibroblasts will migrate to the center of the wound, and it is very uncomfortable for patients to be hooked up to such a bulky device. In the same way, patients can be hooked to a hyperbaric oxygen in which 100% pressurized oxygen is applied to the wound to increase oxygen present and hopefully cell migration towards the center of the wound. Magnets are also used to clear away dead skin from the wound, which can help heal the wounds faster. And finally, skin grafts are used but incur many complications.
So as noted, efficacy, availability, and cost effectiveness continue to be issues in modern chronic wound treatment. Stem cell treatment is not one in which is available for patients today due to its limitations. But one such, our experiment focused on Mesenchymal stromal cells, and these are stem cells located in the bone marrow that secrete certain growth factors that allow for tissue repair. And for the skin cell process, in order to heal the wound, this tissue is very important. So in order to determine whether these stem cells can actually benefit wound healing and improve the wound healing process and better improve the treatments mentioned, we performed this migration assay. And basically, it's just a fancy name for making a wound in a dish in a lab. And the assay comes from, we performed it by growing dermal fibroblasts, which are just skin cells, grown to a certain congruency, or in our experiment, it was a comply in growing skin cells in a single layer. We scratched this group of cells in order to simulate a wound. And the wound healing process was measured by analyzing the width of the wound over a certain period of time in two different media. One being regular tobacco-Z modified eagle media, and this is just a standard stem culture media. And the other one was the same media but conditioned with these Mesenchymal stromal stem cells. A note of the conditioned media, it is not one in which the stem cells are actually present. It is actually one that, as you see in this next diagram, this process shows how we actually condition this media. So during the wound healing process, these stem cells aren't actually present during the wound healing process. So we take the standard stem cell culture media, which you can see shown in the light blue, and the small purple dark blue circles are the stem cells which were incubated in that media for a certain period of time. The stem cells were then collected and filtered for a solution that was diluted. The idea was that any secretions by the stem cells, anything that they emitted, would help facilitate the migration to the brain. So our idea is that the stem cells actually improve this nutrient and have the potential. Our whole objective in this experiment was to prove whether or not this was true. So for our actual experiment, the first thing we did before the procedure actually started was we cultured skin cells at body temperature for about 24 hours until they reached confluency, which just means that there was enough cells tightly packed in a single layer that we were able to perform our assay. So then on the first day, or day 0 of the beginning of the experiment, we created a scratch by taking a pipette tip and scratching it along the well plate with the cells in it, and that created an empty space that we would be able to measure the migration of the skin cells over time, and this represents our mood. And then, so over a period of 48 hours, day 1 to 3, approximately every 6 hours, we measured the fibroblast migration towards the closure of the wound, and afterwards we were able to analyze our data. So we had 4 different treatments that we applied to the fibroblast to see which would be most effective in causing the fibroblast to close the wound. So the first one was just regular DMEM media with 10% fetal bovine serum. And fetal bovine serum is just a serum that contains nutrients that the cells use to survive. So it allows them to grow and live and then migrate. We also used a DMEM media with 0.1% fetal bovine serum, or FBS, because we wanted to see how the cells would react to not having those nutrients and whether or not they would still migrate. And also we used this media with the stem cell media because we didn't want the nutrients from the fetal bovine serum to conflict or overpower whatever proteins were being emitted by these stem cells. So the other 2 media that we used were media that had been cultured in stem cells for either 24 or 48 hours. Once we actually took photos of these cells over the 6-hour window period, and we were able to use a program called Assay to measure them. And so we took 3 axes on each scratch, and we were able to measure how much they closed over time and plot those on a graph. And so we used 3 axes so that we could average them to see how much the wound closed, because some parts of the wound closed more than others, depending on the fibroblast, and also so that we would be consistent with which part of the wound was closing. It can also just be noted that even before day 2 of the experiment, some parts of the wounds with the stem cell media actually completely closed. So as we predicted, the fibroblasts in the stem cell media migrated faster than those in the DMEM or the variant in our control media. So these graphs show they represent the wound width over a period of 48 hours measured periodically. And so in this graph on your left, you can see the red line, which represents the 48-hour culture, the yellow, which is the 24-hour culture, and the blue and the green, which are the DMEM of those without the stem cell media. So the red and the yellow obviously migrate faster to close the wound, and this was our primary experiment. However, we wanted to test which was more effective, the 24-hour or the 48-hour stem cell media. So we performed another experiment, which would be this graph on the right, to see which was more effective. However, we ran into some issues with this, and as you can see, the yellow is moderately consistent between the 2 graphs, meaning the 24-hour was consistent. However, the 48-hour was differs between the 2 graphs, and the grades are not the same. So although we were able to conclude that the stem cell media did enhance fibroblast migration, we were unable to differentiate which was more effective, the 24 or the 48. And some of the flaws that we ran into were natural human error. We had inconsistent scratch sizes, so some wounds that we had simulated were larger than others to begin. In addition, we only performed 2 experiments, and dealing with living organisms, they will not always perform
batch of cells is different and it produces different amounts of protein. And also, we only measured across the horizontal axes, as Lindsay explained, so we weren't able to measure any vertical motion of the cells, so that also contributed to the differences between the crops. The next experiment we performed was called the ELISA, which is an enzyme-linked immunosorbent assay, in which we tested the levels of the protein interleukin 8, also known as IL-8, in both the media we used. The reason we chose this protein as opposed to other proteins known to be secreted by the mesenchymal stromal cells was because past research shows that the IL-8 enhances fibroblast migration. So the results of this showed, obviously, by the bar on the right, which is the stem cell media, lots of this protein has been secreted by the stem cells. So from this, we speculated that it correlates with the fact that the stem cell media enhance fibroblast migration. So we speculated that the IL-8 is the primary contributor which induces cell migration. So overall, we concluded that the stem cell media enhanced fibroblast migration, while the 24-hour was consistent, 48-hour was slightly inconsistent. And from the ELISA, we concluded that the protein IL-8 has been secreted by the stem cells. From this, although we know the IL-8 is secreted by the stem cells, we are not sure of the role of this protein because there are other proteins secreted by the stem cells, so other proteins could have an effect. So in order to verify the role, we could use an antibody to essentially block the IL-8 from doing its job from enhancing cell migration to see if that makes a difference, or to compare a purified version of this protein to the mesenchymal stromal cell conditioned media to see which produces a greater effect, to see whether it's the IL-8 in the stem cells or the IL-8 by itself. If in fact it is the IL-8, then we could genetically manipulate these stem cells to increase more IL-8 or use the IL-8 to assess the stem cells for quality control. And essentially, as chronic wounds really are gaining prominence now with an increase in the number of patients who are diabetic, obese, or elderly. So our results from this experiment really show potential in the field of dealing with wounds, especially chronic wounds.
Right, we'd just like to acknowledge the people, especially our mentors, Renee, Melissa, and Ashley, who helped us significantly on this project, and Dr. Francois Bertillon for allowing us to work in his lab, and as well as the entire GSET program and our sponsors. So thank you, and are there any questions?